We can clean up a little bit. What do we get up top? How many x squareds do we have? We have a x squared and we have a minus x squared, right? Or minus 2x squared. So that leaves me with negative x squared, okay? And then how many x's? They're gone. So I just have plus 1? Plus 1 all over the denominator, right, squared. That's my derivative, yeah? Kind of cleaned up. I would like to know where that's 0. Where's this derivative 0? So what did I just tell you about fractions? But what I tell you, when you try to have a fraction, when we're trying to set that whole thing equal to 0, what do you consider? Just the top, right? So if I set this whole thing equal to 0, all I really have to do is set the top of that equal to 0. And that, hopefully, there's a couple of ways you can do this. Yeah, you could factor it. Here's one thing you could do. You could add x squared to both sides, right? And then you take the square root on both sides. So if you do that, you get plus or minus, because you have to take square root. And you get plus or minus 1 equals x. That's one way you could have done it. Two answers, 1 and negative 1. The other way you could have done it is you could have maybe rewritten it as 1 minus x squared, like that, equals 0. Just change the order of these, and then see that as a difference of squares. 1 minus x, 1 plus x equals 0, and then set each factor equal to 0. You get 1 and negative 1 as well. Doesn't matter how you do it. How many critical numbers do we have? 1. Why? We have to look at the domain, right? Look at this. We're only looking between 0 and 3. So even though we got two answers, negative 1 and 1, only one of these appears in here, right? So for us in this problem, x equals 1 is our only critical number. I'm out of time here, but I'm going to keep going. Now I want to know where the derivative doesn't exist. So look at your derivative. The only time this derivative would ever be bad or something terrible would happen is if the bottom was 0, right? We already know that that can't be 0. We already went through that work, didn't we? So there's no problems with this derivative. The top is a polynomial. There's nothing crazy that could happen up there. So nothing applies, right? So here's the final step. I've got the critical numbers, right? I only have one. I'm going to take that critical number, and I'm going to take the two endpoints, and I'm going to plug them into that function. I'm going to compare the three results. So I'm going to be doing f of 1, f of 0, f of 3. Let's see how fast I can do this. Remember, these are going to the original function, right? I'm going to plug 1 into this, then I'm going to plug 0, and then plug 3. Okay, when I plug in 1, what do I get on top? On the bottom, when I plug in 1, I get what? 1. Should get 1 there. Okay, now plug in 0. 0 on top, and then 0 on the bottom. You get 1, so 0 over 1 is 0, okay. And then plug in 3. On the top, I get 3. On the bottom, 9 minus 3, 6 plus 1, 7. 3 sevenths, right? Is that right? Yeah, 3 sevenths. Okay, what's the biggest number here? 1. This is our absolute maximum. And this, which one? 0 is our absolute minimum. Absolute. I don't know what it is. I don't care what it is. I'm only looking for the absolute, right? So what I'd like for you to do for homework out of here, I have just started to scratch the surface in terms of I've only given you really one function, but theoretically you know how to take derivatives, and theoretically you know how to solve equations because you took college algebra and pre-calculus already. So the concept is just look at the domain, figure out where the derivative is 0, figure out where it doesn't exist, plug those numbers in, take a look at the answers. That's all you have to do. But the functions are going to be the challenge, right? So for 4.1, I just want you to focus on 23 through, we'll go to 43 odds, and I know you're going to have trouble, so just do what you can, all right? I will say that 23 through 35, all they want is the critical numbers. That's it. Find the critical numbers. And then 37 through 43, they want you to actually figure out the absolute max and min. All right, everyone, do your L'Hopital homework. Have a good weekend. We'll see you next week, right?